Let's talk about graphing slope-intercept form. By the end of this video, the hope is that you will be able to graph linear equations in the form y equals mx plus b. Let me say that again. Graph linear equations in the form y equals mx plus b, and for emphasis, y equals mx plus b. Have that in your head. Let's not forget that. Let's remember that guy right there. Why don't we put him down in the corner so we don't forget about him? That is a very, very important equation, and we've been talking about it for the last couple videos. We've been more interested in the slope piece, the coefficient on x, and today we're going to learn what this last piece, b, which I said is the y-intercept. What is that about? How does that apply to graphs? Well, by means of an intro and to warm us up and remind us where we've been, let's start by graphing a line in standard form, a linear equation in standard form. Now remember, standard form is this: ax plus by equals c, where a, b, and c are all constant or are all integers. There's a coefficient on x, on y, they are on the same side of the equation, and c, a constant, is on the other side. There are no fractions, so we are in standard form, which is good, so we can graph this now. So let's go ahead and do that. So let's find our y-intercept, and let's let x equal 0. If we do that, then we will have 4 times 0 minus 2y equals 12. So negative 2y equals 12. And we'll have y equals negative 6 for a point of 0 comma negative 6. That's a bad 0 right there. Okay, so let's plot that. We are at the origin, and we count down 1, 2, 3, 4, 5, 6. Make that point right there. That is 0, negative 6. That's our y-intercept. Our y-intercept. Okay, that was our y. So let's now find our x. Our x-intercept will be where y equals 0. So let's make y 0. Let's let that be 0. So let's say 4x minus 2 times 0 equals 12. So 4x equals 12, and x will equal 3 for a point of 3, 0, because it's the x-intercept, and so y will be 0. So let's go to the origin and count out to 3. There we are. So let's plot this now. We have 2 points, which means we now have enough to make ourselves a line. So let's do that. Let's plot right through that line right there. Let's actually make this a little skinnier if we can. Let's see if we can select this so we can see a little better what's going on here. Good, okay. And let's extend this right through those points. It's a line, right? So it extends forever in each direction. All right, so there we just plotted a line given the standard form. And we've done this a couple times. We've set x equal to 0 to find the y-intercept. We've set y equal to 0 to find the x-intercept. We've plotted 2 points. We've drawn a line. Not too bad. But once again, Charlie the dinosaur is down here begging the question, is there no other way? We should always be asking questions like this in math, because there are several different ways that we can go about solving all sorts of different types of problems, and it's great to have them all in our head. So Charlie, you're rewarded today because there is another way. And of course it deals with slope-intercept form, which we've been talking about. So let's see what happens when we put, actually don't need this graph here, when we put our original equation into slope-intercept form. So that would be this right here, this equation, 4x minus 2y equals 12. Let's bring that down. Let's put that into slope-intercept form, which we remember is y equals mx plus b. All right, do you remember how to do this? Well, we're going to need to isolate y. We're going to need to use our algebra. So to get y by itself, so it's in the form of y equals mx plus b, we'll subtract 4x from both sides. We'll be left with negative 2y equals negative 4x, right? We're going to write the x term first, equals 12. Well, we're not there yet. We now need to divide by negative 2. All parts need to be divided, right? If we divide both sides of the equation, then every piece, every term needs to get divided by it. Okay, so the negative 2's will cancel right here. They will reduce to 1, so we'll be left with y equals, and then negative 4 over negative 2 will reduce to 2 over 1. So we'll have 2x, and that will be plus 12 over 2 reduces to 12 over negative 2, negative 6 over 1, because it's a negative 2. So we'll have y equals 2x minus 6. And look at that. That is in the form of y equals mx plus b. So let's just check for a second. How does this relate to our graph? If we have y equals 2x minus 6, let's group all these right here and move it up. All right, let's explore the graph we just made, but now through the lens of slope-intercept form. Y equals 2x minus 6. And remember, if this is y equals mx plus b, what I told you was that m, the slope, should be this piece right here. So our slope should be 2 over 1, which is up 2 over 1, a rise of 2 over 1. And I also said that the y-intercept, where the graph crosses the y-axis, should be at negative 6. So the y-intercept should be negative 6. Well, let's check. All right, where does the graph cross the y-axis? Negative 6. What do you know? Right down here. So we're good. And what about the slope, the rise over run? We should be able to go up 2, so and over 1, and be right back on the graph. And look, we are. So let's do it again. Let's go from that point. Up 2, went up 2, and our run is 1, and we are back on the graph. And let's go up 2 one more time, over 1, and look, we're right at that second point up on the x-axis. Well, this is pretty neat, because if we have a graph in this form, y equals 2x minus 6, we could graph it right away, because we'll know the y-intercept and then we know the slope. So we can move up 2 over 1, up 2 over 1, make a bunch of points, and plot our graph. So that may not have all made sense at once. So let's see a couple examples and see how this works out, plotting using slope-intercept form. All right, so we have a couple equations right here. And as you notice, they are in fact in slope-intercept form. So let's make sure we remember it. What is slope-intercept form? Y equals mx plus b, where, and make sure that you have this clearly written out for yourself somewhere, what each of these pieces mean. Where m is the slope, and where b is the y-intercept. So make sure you have that. That's very important for you to remember and to have in the back of your mind. So let's group that, and let's move that down to the bottom of the page. Whoops, didn't mean to get that in there. Let's see if we can. Control Z is just a brilliant, brilliant thing. All right, now we'll group that. Okay. So let's try to graph these two equations that we just saw right here. Y equals 2x minus 3. Let's start with this one. Is it in slope-intercept form? You tell me. Is it? Are we ready to go? Can you recognize if it's in the form that we want? Y equals mx plus b. Indeed it is. Look, we have a slope of, if we could write this out, just by looking at it, you know right here that the slope is 2. Or, if we're going to graph it with rise over run, 2 over 1. Well, what's the y-intercept? The y-intercept is that last piece. So the y-intercept is in the place of b, and y equals mx plus b, and that equals negative 3. Or the point would be 0, negative 3, because it's where it crosses the y-axis and x is 0 there. So let's plot the y-intercept. That's our first step. The y-intercept is at negative 3. And now we can plot our graph, and watch this. This is pretty cool. Our slope is 2 over 1. So let's go up 2, 1, 2, and over 1. A rise over run. So up 2 over 1. Rise over run. Up 2, 1, 2, over 1. And we can just keep doing that the whole way up the graph until we just run out of space. And you know what? You can do the opposite. So instead of going up 2 over 1, we can go down 2 to the left 1, down 2 to the left 1. and we could plot off the bottom of the page that way. So that is plenty of information for us to draw a graph now. So let's draw our line right through those pieces. And there you go. We've drawn our line. We can extend that forever in every direction. We know that it has the right slope. We know that it has the right intercept. So that is a pretty neat method for you right there to be able to plot. I'm just going to make it smaller so you can see the points maybe a little more clearly through there. So again, what we did, we plotted the y-intercept first. Well, first we made sure that it was in slope-intercept form. It was. We plotted the y-intercept, and then we did the slope. We went up 2 over 1, up 2 over 1, and we kept doing that up 2 over 1, up 2 over 1, until we had enough points to clearly make a line. Now remember, you only need 2 points for a line, but if we only make 2 right here and they're pretty close together, chances are we might be off unless we have a really good straight edge. So it's often a good idea to make several points so we'll make sure that we have a nice straight line. Okay, let's try another one. Is this equation, y equals negative x plus 4, is that in the form of y equals mx plus b? It looks like it is, and in fact it is, but let's be careful. Let's make sure we know what to do with something like this, negative x. That slope is really negative 1, or we could say negative 1 over 1. So we would go down 1 over 1, down 1 over 1. What's the y-intercept? Well, b equals 4 in this case. B is 4, positive 4, so that point would be 0, 4. So let's plot that point. First step, let's plot the y-intercept. B is 4. And our slope is negative 1, so down 1 over 1. So we start, and we're going to have a negative slope. Remember, a negative slope means that we are going downhill. Positive slope, we're going uphill. No slope means that we're a vertical line. We can't do that. We'd be divided by 0. And 0 slope means that we are flat, as would make sense. All right, so there's a bunch of points going down 1 over 1, down 1 over 1, or the opposite of it, up 1, up and to the left, up and to the left. That is plenty to draw a line. So we'll draw a line right through all those points right there, and we are set. We did it. We drew our line using slope-intercept form. Cool. All right, 2 more examples, and we'll up the challenge meter just a little bit. So 4x minus 5y equals 15. What do you notice about this right away? What form is this in? This is in standard form. But we don't want standard form. We want y equals mx plus b. So let's put it in that form, and we're pros at this now. Let's isolate y by subtracting 4x from both sides. We'll then have negative 5y equals negative 4x plus 15. We need to get y by itself, so we're going to divide by negative 5. Each term, every term gets divided by it. So we'll have y equals, well, negative 4 over negative 5. The negatives will cancel out, so that'll be 4/5 x. Oh, and again, it's y by itself now because negative 5 over negative 5, that will simplify to 1. So y is now isolated by itself. And then we have 15 minus 5, so that will be 15 divided by negative 5, that will be minus 3. Okay, so now we're in the form of y equals m, which is 4 over 5 in this case, x minus 3, and that's the plus b part. So in this equation, I'll use a different color, m equals 4/5. That is our rise over run, 4/5. And b equals negative 3, our y-intercept, which is the point 0, negative 3. So let's plot that. Our y-intercept is negative 3, and now let's have some fun plotting the slope. Our slope is 4/5, so we go up 1, 2, 3, 4. We go over 5, 1, 2, 3, 4, 5. We'll go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, and we're at the edge of the graph. And that's enough that we could plot this line, and just for good measure, I'll plot it the other direction. So the opposite of up and to the right would be down and to the left. So I'll go down 1, 2, 3, 4, and to the left 1, 2, 3, 4, 5. And we could go down again, but we're off the graph, so we'll just leave it there. And we will plot this one now. Let's use a different color. Let's go pink, just for fun. Let's go with a pink line, and let's make it a little smaller so we can see our points. And you can always check to make sure that we have the slope intercept. Yeah, we are at our y-intercept is -3, and if we will go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, we are back on the graph. And we have plotted a linear equation using slope-intercept form. Way to go. One more. Let's make sure we're all on the same page and good at this now. So you might want to pause this one. Try it on your own. See how you do by putting this into slope-intercept form. All right, we will subtract 2x from both sides. Now be careful here. See how it's 2x minus y? Make sure you keep that negative. It's negative y now equals negative 2x minus 4. Is that in slope-intercept form? It looks very close, but the only difference is this negative right here. We want everything to be, we want y, to be positive. So to do that, we'll have to divide everything by -1. Really, you could flip the sign on everything, but to make sure our math is consistent, and speaking of math being consistent, did you see what I forgot? I forgot my x right there. -2x. So divide everything by -1, and our equation will now be, after the negatives cancel, y equals, and then -2 over 1 will be +2, so 2x, and then -4 divided by -1 would be +4. Can you identify the slope and the y-intercept now? Well, our slope will be m equals 2, or 2 over 1, and b, our y-intercept, equals 4, and that point would be 0, 4. So let's plot that. 0, 4 would be 1, 2, 3, 4, and our slope is 2 over 1, so we go up 2 over 1, up 2 over 1. And we could also go down 2 to the left 1, the opposite of that, down 2 to the left 1. And we could plot that for as long as we wanted, moving down and to the left 1. So there you go. There is the outline of our line. Let's plot it now. Let's use pink again. Whoa. Not what I meant to do. I meant to do a line on there. All right, here we go. Let's do a line. All right. So there's our line. We'll make it smaller so we can look at what's going on. And notice we did it again. Good job. We used standard form. We turned it into slope-intercept form. We watched our negatives all the way. We used our algebra, and we found a slope. We put it in the form y equals mx plus b. We noticed the slope was 2, which is really 2 over 1 for slope, so up 2 over 1. We identified b, the y-intercept, which is 4, which is the point 0.04. We plotted that, and that was our starting point. Starting point was the y-intercept. We went up 2 over 1, up 2 over 1. We did the opposite. We went down to the left 1. We plotted our linear equation. Well, great job following along. To make sure you've got it all, answer these questions right here. What do the values m and b represent in the equation y equals mx plus b? What is the y-intercept? What do we mean by that when we say b is the y-intercept? And finally, list the steps, your own steps, for plotting a linear equation from slope-intercept form. All right, guys, great work today, and we'll see you soon.